Okay, let's do some ratios on the coordinate plane. On this question, it says Maggie walks at a constant speed and she plots points on the coordinate plane below to show the amount of time it takes her to walk certain distances. So I'm going to take this graph that they give us here and I am going to plot it in my other little chart to make it easier for me. So I know that we are comparing her hours, so I'm going to put an H for hours, to her miles. When I go across to the hours, for 2 hours, she was able to walk 7 miles. So 2 hours went with 7 miles. If I go over here, I see that 4 hours, she was able to walk 14 miles. So 4 hours, she walked 14 miles. If I keep going, I see that she walked, let's see, what is that, 17 in 5? They have it right in between, so we can't really tell. See if I can zoom in on this thing a little bit. Looks like she walked 17 and a half. So maybe like 17.5. I'm not 100% sure what that is, but we shall see. To get from 2 to 4, I can add 2. To get from 7 to 14, I can add 7. I put this number on top of this one, 7 over 2, and I know that is my constant rate of change. So each time I can multiply my hours by 7 halves and it will get me the number of miles. So let's see. We're going to start off with A. They want to know if A can be added to it. So I'm going to take X, which is my hours. Let me scribble this out so it makes it a little easier for you. I'm going to take my hours and multiply that by 7 halves, and it should get me my miles. So here they told me that in 1 hour, she can go 3 miles. So I'm going to take 1 and multiply it by 7 over 2. 1 times 7 is 7, and 1 times 2 is 2. Hmm. So this says that she can go 7 halves. This is saying 3. That's not the same thing, so that won't work. Let's try B. Remember, each time we're multiplying our hours by 7 halves. So my hours for B, 3 hours. I'm going to multiply that by 7 halves because that's my constant rate of change. That's like 3 over 1. 3 times 7 is 21. And 2 times 1 is 10. Sorry, 2 times 1 is 2, not 10. 21 divided by 2 does not get me 10, so B will not work. Let's try out C. C tells me that if she takes 6 hours, she should be able to go 21 miles. I don't know, but I'm going to check it out. I'm going to multiply it by 7 halves. That's 6 over 1. Uh-oh. It's supposed to be 6 over 1. 6 times 7 is 42. And 2 times 1 is 21. Sorry, 2 times 1 is 2. I don't know where I'm coming up with this foolishness from today. 2 times 1 is 2. When I divide 42 by 2, then I get my 21, which is what I'm looking for on C. I will try to not get confused on the other one because it was getting you guys confused when I was rambling on and on. But let's try this out just to see. Callan goes for a hike every Saturday and he hikes at a rate of 3 miles per hour. So that means I take my hours and I multiply them times 3, and that gets me the number of miles. So 3 times 3 would get me a 9, and 5 times 3 would get me a 15. I now need to plot these points. We plot points in X, comma Y. That's the order that we plot them in. X comes before Y in the alphabet, so we make sure that our X's go before our Y's. So on my first one, I have 1, 3. My X is 1, my Y is 3. My X tells me to go left or right, and my Y tells me to go up or down. So I'm going to take my first dot, I'm going to go to the right 1 to represent my X, and then I'm going to go up 3 to represent my Y. On the second one, my ordered pair was 3, 9. I take my 3, make sure I have my dot over here where it's at, but then for my y, I need to go up to the 9. So now I have plotted 3, 9. My last one that I'm plotting is 5, 15. So I go over to the 5, boom, and then I have to go up to 15 to represent my y. So let's double, oh my goodness, I almost put that in the wrong spot. There we go. I had it at 5.5. You have to make sure it's on the right line, otherwise you will get it wrong. And we're done. On this one, they're talking about Richard. He went to a zip line park for his birthday, and he travels on the zip line at a constant rate. The points on the following coordinate planes show how many feet he traveled in 2, 3, and 4 seconds while riding one of the zip lines. How far does he travel in 1 second? Let's figure out what numbers we have here. I know that in 2 seconds, he traveled, let's see, 50, 60, 70, 80 feet. I know that in 3 seconds, he traveled 140 feet. And I know that in 4 seconds, I'm going over to the seconds at the bottom. This is where I'm getting this information from. So 4 seconds, and then I go up to the distance. It was 160. So 4 was 160. Every time I'm multiplying by 40, 2 times 40 will get me 80. 3, why did I write 140 here? This is supposed to be a 120. Goodness, writing some foolishness. 3 times 40 gets me 120, and 4 times 40 gets me 160. The question that they're asking here is, how far would he travel in 1 second? Just like I multiplied everything else times 40, I have to multiply my 1 times 40, and I end up with 40. So the answer, whoa, I almost typed some foolishness here. So the answer would be 40. Last one. McKenna is earning some money each time she shovels snow for her neighbors. She plots some points on the coordinate plane to show how much she earns from the different number of times she shovels the snow. So let's figure this out. I'm going to compare the times that she shovels with the dollars that she makes. When she shovels 3 times, she made 18 bucks. 3 times, $18. When she shoveled 4 times, she made 24. So 4 and 24. When she shoveled 5 times, it looks like she was at 30. So 5 times made her $30. As I'm looking here, I notice that I can do 3 times 6 to get 18, 4 times 6 to get 24, and 5 times 6 to get 30. Since they're constantly multiplying by 6, in order to add another point to the graph, I have to multiply by 6 as well. A will not work because 1 times 6 is not 10. B will work because 2 times 6 is 12. C will not work because 6 times 3 is not 34. That is why our answer has to be B.